So I take out a 3x cubed, it leaves me with x squared plus 4x plus 4. And then I factor this, I get 3x cubed times x plus 2 squared. So there it is, fully factored, and now I can find the zeros with the multiplicity. So x equals 0, that has a multiplicity of 3, and that goes through. And then negative 2 has a multiplicity of 2, and that bounces. Because this is like 3 times x times x times x. What did you say? What did you need me to go over? Nothing? 9, number 9. Noah, number 9. All right. X squared goes into 2x cubed how many times? 2x. Multiply around 2x cubed minus 10x squared minus 10x, and I subtract. This goes away. Negative 11x squared minus negative 10x squared leaves me with negative 1x squared. Negative 5x minus negative 10x leaves me with, that's where y'all say positive 5x. Drop down the next one, thank you. What do I multiply to get negative x squared? Negative 1. Multiply through, I get negative x squared plus 5x plus 5. I'm subtracting all of these. These first two cancel out. I've got 4 minus 5, which is negative 1. Leaves me with a remainder of negative 1. You can either say plus negative 1 over that, or you can say minus 1 over square minus 5x minus 5. Either way, that or that would work. But do not, this is a lot of you, and I don't think that I took off. If I did, it was very minor. This is not the same as this. Even like that. That means you're multiplying. And so if you see yours, I'll probably put a big plus in the middle like that to let you know that you are adding and not subtracting, or you are not multiplying it. Does that make sense? Huh? All right. What else? Okay. Okay. What? 4. I have one. I just don't know where it is. A lot of you missed 4 too. If I ever see my leading coefficient being negative, I always factor out a negative to start with. It's just a good habit to be in. It helps you out. So GCF here, I took out a negative 3x squared. Leaves me with 9x squared minus 4. This then is the difference of 2 squares. If it's a plus, you can't do it. It has to be minus. But it's negative 3x squared times 3x minus 2. 3x. Oh. Basically, close hand counts and horseshoes and hand grenades, buddy. Not even close. What else? Y'all okay? And you don't know how to do it? Are you telling a story, David? You are telling a story. Let's look at your homework from last night. Take that out. Number 2.
Every single one.
I don't know if I'm doing this good. I didn't want to do it.
I didn't want to do it.
3.
You don't have to remind it. You just factor it.
This one's slash.
Yeah, you can slash it.
No, I tried that.
Yeah, well, I tried it too. I got it right.
This one does slash. Let's do one that doesn't slash.
That's all you have to do?
This one, if you can factor, always let that be your go-to. Your last ditch effort is a PRZ. If you can do anything else to get it manipulated to solve, then do it. Well, you can still list them. The PRZs, that's nothing. That's just factors of the constant divided by factors of the leading coefficient. So that'd be, okay, 1, 2, 4, 8, 16. And then I take all of those and divide by 3. It's not a square root. Okay, so every actual zero is not necessarily contained in this list. I see what you're saying now. Because square root of 8 is not on that list, but that's one of the zeros. You're right. They don't necessarily, all the real zeros are not necessarily in that list, and everyone on that list are not necessarily actual zeros. It's just a springboard for you to try. Yeah. Possible zeros. Well, you list them. That's just part of the practice of the problem, so you know what it is you're. But let's say I couldn't factor this. Let's say I looked at this and I went, I didn't think that I could slash it, right? So let's say that I tried, because I know algebraically that negative 2/3 is one of the zeros. Agreed? Well, I'm looking at this. Okay. So let's say I didn't have this, and I was going through this list of values, and I get to negative 2/3. It's okay. It's just a fraction. I'm saying if I didn't factor it. But yes, you can do synthetic. All right, so negative 2/3 times 3 is negative 2. Right? Why? Oh. I thought you were talking about what I added was wrong. I mean, what I multiplied was wrong. That's a 0. And that's a 0. And that's a negative 24. 16, which gives me 0. Now look what happens here. That means that I could factor this as x plus 2/3 times 3x squared minus 24 to be factored, right? And if I continue to factor this, I could take a 3 out of both of these, x squared minus 8, which is what I'd end up with here if I'd have factored. And whenever I set equal to 0, I get negative 2/3. X squared is 8, which means x is plus or minus square root of 8, which of course is 2√2. So even if you didn't recognize that it could factor there, I could still go here and do that with the PRZ, if that makes sense. No. Did you? Did I give you all ones that can be factored? Yes, all of those can be factored. Dang it. We do need more practice with PRCs and plugging in and factoring. We will. 24 and 1. 1 through 4 can all be factored. I should have made you do PRZ on the back on 9 through 11. I bet those were the ones. Yeah, you did. Yeah. 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 Let's do 11 because it looks the hardest. Let's do 11 together, but let's do it. Let's do it.
All I had to do was do it right.
Why did we do 11 in class? I'm still doing it anyway. All right, so I'm going to go start to finish on this. I'm going to list the PRZs. I'm going to test the PRZs. Actually, before I test, I'm going to use the carts to tell me what my signs, what my possibilities are going to look like. and then I'm going to start testing PRZs, and then I'm going to factor and find the zeros. Okay, so I'm going to do start to finish. This is everything we've talked about with these. So this is an all-in-one. You were, but I'm going to take this one a step further just to show you, because I thought 1 through 4 we're going to do this. Yeah. All right, so first off, let's list the PRZs here. 1, 2. Everybody sees where that first list of numbers is coming from. Those are all the factors of 12. Now, I took the factors of 2 are 1 and 2, right? So now I also need to come in and divide every one of those by 2. So, well, what we do is we take all of these factors and we divide it by every single factor here. So let's say if this was 10, right, exactly. Yes. You don't need any repeats. I'm taking all of these numbers, Kate, and now I've already divided them by 1. That just gives. Now I'm going to divide them all by 2. Right. 2 divided by 2. I don't need repeats. Okay, 1's already in my list. 3 divided by 2 is not in my list. Is 4 divided by 2 in my list? 6 divided by 2. 12 divided by 2. These are my PRZs. So. All right. Now let's look at Descartes. How many positive solutions might I have? 2 or 0? Because look how many sign changes do I have? 1, 2. So 2 or none. What? No, I'm just showing you. All right, now negatives, right? Now here's where I do have to think about this. If I make this negative, that means every even exponent stays the same. Every odd exponent changes sign. So this is 2x to the 4th minus 5x cubed minus 31x squared plus 10x plus 12. Y'all okay there? Yeah. Now on 8, all you have to do is list how many positive and negatives, so you don't actually have to find them. But it doesn't take into account imaginary solutions. That's why it doesn't. But that's okay. 1, 2. Yeah, you subtract 2 each time. 1, just 1. That means, and that's the best one because then you know you've got one of those kinds. None. You say none. So if I didn't have any sign changes in here, if they were all the same sign, then I would say you have no negative solution, which would eliminate half of your list. Is 3 a 0 here? Looks like it.
She's still doing well, even if you add in 0 there, you can flip the sign so you can still do it.
Because I used my calculator to see where it was from. I didn't want to start going through all of these. That's not the solution, that's how many solutions. So 2 positive solutions, or no positive solution. You won't get, if you get just 1 positive solution, you've done something wrong because there's got to be either 2 or none. All right, so I've got 2, 6, 11, 30. I've never really been a fan of Descartes. I've never really thought it was as helpful as what other people think it is. But because I graphed it on the calculator to see where it was crosses, where it crossed to give me an idea that maybe to plug in. Okay, so whenever I can't factor, right, to find the zeros, there's no way, I can't slash this, there's nothing I can do. I have to start taking these PRZs and testing them to see which one is a factor. How do you know it's a factor? Whenever I divide and I get 0 here. How do I know where to start? I cheated a little bit. I took the calculator. Now, I know that x equals 3 is a solution. How do I know that? It didn't have a remainder. So tell me what else I know based on Descartes if 3 is a solution. Not necessarily. There's another positive solution. Because it's either 2 or none. It's not none because I have 1, so there must be 2 positive solutions. Does that make sense? Do you see how I'm using Descartes to kind of move my... Okay, so I've got x minus 3 times 2x cubed plus 11x squared plus 2x minus 4. But I have to finish factoring so that I can get all the zeros. So now I'm back to this one. Can I slash that? No. I mean, I could try, but it's not going to work. Why is it not going to work? That 11 is throwing me, right? So I'm back to PRZs, but I'm going from that same list of PRZs, and I'm going from my same thought process of Descartes. I'm probably going to try another positive because I know it has at least one more positive. And so maybe I try a half. I was going to say, why might I try a half? Where did I just pull a half out of the air? My calculator looks like it's probably crossing at about a half. Let me try a half and see if it works. But this time, I'm only going to use this part. So I've cut my work down a little bit, right? 2, 11, 2, negative 4. So 2, 1, 12, 6, 8, 4. Did it work? Yes. Now I can continue factoring. So now I have that x minus 3 is still there. And now x minus 1 half, or 2x minus 1, however you want to write that. That would be the same thing. Times 2x squared plus 12x plus 8. Even if I can't factor now, I'm down to a quadratic, and I can do anything I want with a quadratic, right? Because worst case scenario, I'll use quadratic formula. Exactly. I'm going to take a 2 out of all these, though. X squared plus 6x plus 4. Does this factor? Oh, gross, it doesn't. I must be way different. Well, we won't go through all that, but it would be a quadratic formula. Want me to do it? There are my 2, and I'm going to assume that the 2 from the quadratic formula are going to be imaginary because I can't have any more positives, right? Okay, right. Yep. C squared minus 4 times A times C all over 2 times A. 36 minus 16 is what? Could I have kept it what? It's not imaginary, but they're both going to be negative, actually. Because square root of 20 is less than 6. Yeah. You could have, yes. But square root of 5, this is always going to give me a negative number. So look, 2 negatives for AC. A is. Which will give you negative both times. Whether you add root 5 or subtract root 5, you'll still be in negative land. And look at my Descartes. You won't pass, school, probably. Maybe, depends. I don't know. What do you want to go to school for? What do you want to be when you grow up? Yeah. Do you really? You actually might in like your medicine, like calculating like. All right, let's switch gears. I'll do all the dogs. I'll do the
I'm gonna go back and just find her.
Let's take, if these were the zeros of a function, if these were the only zeros of a function, and the 2 has a multiplicity of 2, could you write an equation for the polynomial that would have those zeros? What would it look like? These are zeros. Say it again, Kaylin. Yep. That was a sleigh. Look at you go. Okay. Okay, you are not the first student who has told me that. Years ago, I had a kid named Tony Shaheen, and he said, you remember Tony? And he said, Miss McGee, nobody would ever be able to track you or trace you or something if you, like, wrote a ransom note. What, I don't know what he. Anyway, he said because your handwriting never matches. Because just look at your 2s. Sometimes you write them this way, and sometimes you write them that. But like there is no. It does. Isn't that weird? I don't know. Do you? Isn't that weird? I don't know.
I think I've written 2 like actions. I just like sometimes I'll pick up.
All right. Everybody understands where these factors are coming from, yes? Because really, x minus a 0, and not the number 0, but a 0, go sit down. X minus a 0 is always a factor, and that's where we're getting these factors from. Is everybody okay with that? Okay. However, pointless.
No, it's very fun. That's what I meant. It was a type thing.
Pointless.
X minus a 0 or a solution or whatever name you have, the x-intercepts. They give you a factor. That's where these are coming from. Now, I know. Here's something you don't know. If you have
I've been so very good.
That's an out.
But it's about to come out again.
If this is a 0, well, but actually it does because there's this little conjugate root. Davis, you always roll your eyes at me like that. They're gonna get stuck like that. I literally only see the whites when you do that of your eyes. All right, Logan, get out of my desk. Get out of my desk. The factor is not just x minus 2i if this is a 0, okay? It's actually x minus 2i or x plus 2i, okay? It's what we call the conjugate root theorem. Do you want me to explain why? No, you want me to explain why?
Because whenever you get one of those, it's always a positive or negative.
What happens?
Because mathematicians couldn't say that, hey, I'm wrong, so they made up imaginary numbers.
If you set that equal to 0 and you solved it, right, that's why. That's what, do you see? Listen, whenever we did complex numbers in Algebra 2, if you aren't with us in Algebra 2, listen carefully. Some of us were here, but just not mentally here with us. Okay, so whenever you had a complex number on the bottom, we multiply the top and the bottom by the conjugate of that, because when you multiply conjugates, i's go away. And conjugate just means 1 plus and 1 minus. That's all it means. Only the middle number change, the middle sign changes. A real number and an imaginary number added or subtracted. Okay? So the complex root theorem says if we have a 0 that's an imaginary, bless you, is an imaginary number, then x minus that imaginary number is a factor, but also x plus that imaginary number. This is the conjugate root theorem. Now, why in the world do we need to know this? Theorem. Yep. Now, here's what we're going to do. We're going to build on what we did yesterday. This is getting exciting. You ready? We can write any polynomial.
What is a polynomial?
Are y'all serious right now?
No,
One or more terms, that's right, with positive whole number exponents on the x, okay? Okay. Yes. It's a linear polynomial. No.
How is x plus 1? You can just have an they're really imaginary, certainly not. They don't need to exist. That's gonna miss are wrong.
Okay.
That's like mathematicians are being they have more than that. Somebody got real bored. Somebody actually
You can't flash it. Don't care.
right? Well, you're gonna have to take out some PRG.
Okay. Why is this important? I'm telling you, I want you to write this. This is what we call linear factorization or linearization. We're writing it so that every factor is a linear factor only. What does that mean? X plus something, x minus something. You can have a coefficient but no exponent. Well, most of the time, whenever we factor down, we could get down to a quadratic that just doesn't factor any further, right? Say right, because that's right. Okay. But, because what if it has imaginary numbers, right? What if I got something factored down to this? And I had told you to factor that with linear factors only. This is not a linear factor. I have to make it a linear factor. So to make it a linear factor, I have to first find the zeros. find the zeros, and then, yes, and then I use those zeros to write the factors. So I could have to. I might not have to. The example that I got here, I'd have to. For this one, if I got it factored down to here, well, now at this point, I could say, okay, x squared plus 4, the zeros of that, we just did that. That's plus or minus 2i, right? Which means that this breaks up as x minus 2i, x plus 2i. We're not graphing it. We're just writing the linear factors of the polynomial. Yes. Oh, no. It's not. It was just Slade, get off of it. He's fixing to get in trouble. Okay. Just that.
Get out of here.
Hey, no reference got a write-up for that. Come on now. Just don't walk over there like that.
No, okay, first of all, no. He got a write-up for hitting it and breaking it.
Yes, she did.
Because I looked at him and said, if you touch it, I'm going to write you up. And he walked over there and hit it with his hand and broke it. Don't touch that, Noah. Okay.
WWJD. He hit it that hard?
Yes, it broke. I had to have maintenance come in and fix it.
Touched it. Pretty strong guy.
Back to this polynomial. Okay. All right, let me walk you through because we're going to use these steps. Factor this fully using only linear factors. Okay, so here we go. Can you factor that as it sits? No. So since I cannot factor it, it does not factor, right? It doesn't, Davis, I'm sorry. I said, for instance, if I had something like this and just had one piece that wasn't factored, that's your fault. Okay, so here, when I get to the point where I absolutely cannot factor or cannot factor further, I'm finding the zeros. How in the world am I going to find the zeros of this? And several of you have already said PRZs, right?
Yeah.
So, what should I try first? 1. 3 works? I don't know, I'm asking you. That doesn't work. No, that doesn't work. Shut up. That's. Does those work? You could. What works? Graph it and look at it and see what it works.
4 times 10. 8. What else is 40?
What is that? What's that negative one?
I don't know. 5. Oh, 5.
Stop randomly blurting and give me.
What is 5 times? 5 times what equals 5 times.
Of the function, can you factor it? Y'all say slash. It does not slash.
Alright, so try a little.
PRZ.
Yeah, that one was a terrible first example.
PRZ.
PRZ. If I PRZ it, give me something to springboard on to try.
42. 2. 21.
Like, doesn't it it's a negative number though. So like,
Yeah, it is.
6 and 7.
21.
-7.
Stop it, boys.
-7, -2.
All right, look.
Yeah, you're not really.
Other than the graphing we're doing Monday, this is the hardest thing in this lesson, so you need to pay attention in this unit.
Do something harder?
Get out of that cabinet. Not new yet, right? I am PRZing it. I'm going to find the zeros. Find all the zeros. Mark, set, go. Find the zeros. You should be able to do that. Find all the zeros.
What's 27 minus 13?
Why does that not work? That should work. Oh my gosh.
27 minus 13.
What's 27 minus 13? 14.
I couldn't do that. This is where I'm at.
I wonder why I could be frustrated and not even able to think right now. All right. X minus 3 times x squared plus 9x plus 14. Does everybody agree, and does everybody see where that came from?
Agree.
It factors. Dang it, give me one that doesn't work.
How did you get x squared?
7 and 2. So look, but this is a good example of, okay, you might not have to do it every single time. It just might work.
Yeah, those are all linear factors. Yeah, but what's linearization?
Hold on.
Have linear factors. That was x
Right.
2 squared.
Logan, shut up. $12 and 4 multiplies to 48, but adds to 8, negative 48. 2 and 24, 3 and 16. Okay, I got one. Write the complete linear factorization of this. Mark, set, go. That means factor it completely, but every one of your factors has to be linear. You might, but you might not. Check and see. No exponents on x. Okay, factor. Just factor like you've been doing. Factor completely. Start there. Factor completely.
48.
Agree or disagree? Why? But I'm saying first step. First step. Everybody okay? All right. Logan says difference of squares. I do agree with that. Right now, I haven't done anything past algebra 2. I'm just factoring, right? This is quadratic form, even, half, constant. I'm going to leave this first one alone, but here, you're right. This is a difference of 2 squares. Now, would everyone agree that by... I don't know. I didn't. I don't think. They're not. Which one's the problem? This is the problem. Why is it a problem? Okay, because there's a squared on it. It's not linear. It's going to give me imaginary zeros, right? But I need to know how to break it up so that it is linear factors. So to do that, I have to find the zeros that it creates first. Okay? So x squared plus 12 equals 0. X squared equals negative 12. Plus or minus 2i root 3. Agree or disagree? So if I take the square root here, and then I just split up.
Square root of 4 and square root of 3.
That's right. That's right. Because it's imaginary, I have to do the plus and the minus, but I keep all the rest. And now I am completely linear.
Why don't you just leave it?
This is the complete factorization now. You have to write each one. Linear factorization, or the linearization
We
of
literally
this.
just didn't learn anything. That was like,
That's bullet, yep. That's it.
so,
No, because you're trying to get it fully factored, and in the fully factored, you only want linear factors there. So the point of this is not getting the zeros. The point is the factorization, but you have to get the zeros to get it factored sometimes, which is the case here.
So we turned it into a 0 and then it turned back into a factor.
Yes, that's exactly right. That's